Okay, so the first instance of Western mathematical thinking being applied to the I Ching, probably a lot of you know about this, but maybe not all the detail. The German philosopher, polymath, mathematician Gottfried Wilhelm Leibniz, best known for discovering or inventing calculus, depending how you look at it, almost exactly at the same time as Isaac Newton. You had this strangely synchronistic discovery of differential calculus. That's what he's best known for. He existed at a time when you could pretty much have a very good overview of all human knowledge, all Western human knowledge, before this sort of hyper-specialisation we have now. So he's known as a mathematician, but also he was a theologian, and there was an interesting sort of crossover point that revolves around the idea of binary numbers, binary arithmetic. And in the 1680s, he was experimenting with a number system, a way of representing numbers just involving zeros and ones. Now that should ring a bell. You've all no doubt heard about binary numbers as used in computer technology. And the history of the Western understanding and use of binary numbers goes back to Leibniz, 1680s. And interestingly, he wasn't just interested in it from a mathematical point of view. He believed that it might be a candidate for what he called the characteristica generalis, which was this. He believed there was a sort of basic alphabet of human thought, that human thought could be sort of reduced to some sort of atomic level, and that there were these sort of bits, which is actually a really good word. I didn't really think about that before, but literally bits, zeros and ones. He thought perhaps this binary number system could be a possible characteristica generalis. I don't think he ended up concluding that it was, but he was exploring that. And he also thought possibly it would lead to new mathematical discoveries, that you'd be able to sort of find out certain mathematical truths in this system that you wouldn't in the base 10 system, the familiar system that we all use. That now seems like quite a naive idea, because binary number system is just a way of representing numbers. It doesn't tell you anything new, it's just another way of writing them. So just a quick explanation how this works. So if I put 23 stones in a pile and you count them and I ask you to write down how many stones you found, you do that. But where's the 2? Where's the 3? There's no, if you look to that pile of stones, you don't see a 2 of anything, you don't see a 3 of anything, so why are you writing this? Well, if you think about it for a minute, it's because this refers to 20, in other words, 2 lots of 10, and with 3 left over. So if I put a load of beans or stones on the table, you can count out tens, and then when you've got all the tens, that's the first digit here, and then whatever's left over becomes this digit here. And if there were more beans or stones and you counted 138, again, you count out 100, then you have some left over. Of that leftover, what we think now see is 38. You count out piles of 10, so you find 3 of those, so you've got 100, 3 tens, and 8 left over. In other words, that digit refers to hundreds, this to tens, and this to ones, but there's no 1, 3, or 8 present intrinsically in that pile of stones. It's just a way of representing numbers, and it turns out there's nothing special about 10, despite what your maths education tends to lead you to believe, unless you pursue it to the higher echelons of mathematics. Most people believe there's something special about 10 and 100 and 1,000. They think these numbers are somehow intrinsically distinct because they've got these zeros and they have these nice numbers to work with. The metric system's based on tens. In fact, unless you're getting into sort of metaphysical ideas from Kabbalah or the ancient, was it Neoplatonic idea of the tetractys? I think that's right, iamblicus. There have been mystical ideas that the number 10 is intrinsically important, but from a mathematical point of view, there's nothing special about it. It's just the number of digits we have. These are the digits we use in our system. There are 10 of them. And when you reach the last one, where do you go? You have to introduce a second digit. So 10 is just the first number where you need an extra digit. That's all that's going on. So if you can have base 8, if you only have 8 digits to work with, you throw away your 8 and your 9, you've just got these 8 digits, you can use base 8 or octal notation, and your 23 wouldn't be written like this. That pile of stones that we call 23, you don't count out 10s now, you count out 8s. And you have how many 8s? You have 2 8s, what we call 16, with 7 left over. So that, what we think of as 27, if we look at that, in base 8, that's actually the same as 23 in base 10. What the point of all this is that it's just a system of representation. And binary is base 2, where you only have 2 digits. After 1, you run out of digits. So what comes next? What looks like 10, but is in fact 2. Because in binary, this is the number of 1s, this isn't the number of 10s, this is the number of 2s, the number of, which corresponds to how many digits we're working with here. This is the number of 4s, or 2 times 2, instead of 10 by 10. And this is the number of 8s, we basically double this up each time. And it turns out any number can be represented by adding either 1 or 0 of these, what are called powers of 2. You can break any number down like this. So we can write our 23 as, well, it's 116 with 7 left over, and 7 is, there's no 8s, there's a 4, there's a 2, and there's a 1. So 23 would be written like that in binary. 1 plus 2 plus 4 plus no 8s, but a 16. So in other words, this pile of beans can be written in all these different ways. You could write it in Roman numerals, you could use Egyptian or Mayan glyphs. As you ought to realise, that has no bearing at all on the actual properties of the number. And Leibniz was really the first person to realise that you can switch bases. The base 10 counting system we use was introduced apparently by Pope Sylvester II around 1000 AD, and he got it from the Moors in Spain. It was an Arabic invention. Anyway, what's this got to do with the I Ching? Well, Leibniz had a friend in Beijing, Peking as it was then, a Jesuit father called Bouvet. I don't know his first name. And Leibniz was writing him letters with various sort of theological speculation and this sort of, multidisciplinary, interdisciplinary theorising that he was doing in the late 17th century. And he thought this binary notation was binary number system had a theological importance because to him it had something to do with God creating the world, something out of nothing, the 0 and 1. He linked that to, he witnessed a confluence of several intellectual strands in his worldview, including theological and mystical ideas of order, harmony, and creation. So he's writing about this. He's writing this fairly technical letter about how you do arithmetic, how you add and multiply these numbers, to his Jesuit friend Bouvet. And Bouvet immediately recognised this as the Fu-Si sequence of hexagrams, which I'm sure most of you are familiar with. This sequence here can be seen as the numbers 0 to 63 written in binary in order. In other words, that's 0, 1, 2, 3, 4, 5, 6, 7, where you basically use a yin line for a 0 and a yang line for a 1. And Bouvet had come across the I Ching, living in China for years. He'd come across this particular sequence, and he wrote back to Leibniz with this woodcut, which you might have seen before, which was basically the same thing. I just printed it out in a slightly more visible form. And Leibniz immediately realised what he was looking at, that Fu-Si, or whoever it was, Fu-Si is a sort of mythological character I've been led to believe, but about 4,000 years before Leibniz, somebody had worked out how to write the number 0 to 63 in a sort of binary notation. Instead of stacking zeros and ones horizontally right to left, they were stacking yang and yin lines vertically from bottom to top. That's the only difference. And he thought this was wonderful. He was rightly impressed by the fact that the Chinese had discovered this 4,000 years ago, because even though it might seem to you, once I've explained it, if you've understood the explanation, someone's going to stumble across that sooner or later, it's not that difficult. But in fact, Leibniz was only able to come up with this idea because we'd had 700 years of base 10. As I said, Pope Sylvester introduced it into Europe about 1000 AD. So by 1700 or 1680 something, Leibniz had realised what was going on, and that it was basically an arbitrary thing with this fact you have 10 digits, and you can have 2 digits or you can have 16 digits. It doesn't matter. You can change bases. He changed to base 2, and so he thought, well, the ancient Chinese have forgotten the meaning of what they've discovered. The Chinese lost the meaning perhaps more than 1,000 years ago, and they have written commentaries on the subject in which they've sought I know not what far out meanings, so that their true explanation now has to come from Europeans, that is him. But there's no evidence at all that Leibniz was interested in the I Ching as such. He wasn't interested in what the hexagrams meant. simply in the fact that someone had written them in that order. And as far as I'm aware, that's as far as his interest in the Book of Changes went. And then, if you look on I'm going to hand out a website address later, which is a bibliography of everything I'm talking about. There are several links, including English translations of letters that Leibniz sent to Bouvet and vice versa. So you can find out the whole story in detail if you're interested. And there's also an article from a Guardian website, somebody arguing that basically computer science was all kind of prefigured in the I Ching, that the I Ching should be recognised as the original source of the sort of structure of thinking which underlies all information technology. I haven't actually read that yet, but I linked to it so you can see what you think about that. Anyway, nothing then happened between 1703 and 1950 when Wilhelm, in English anyway, the Wilhelm Danes edition, I don't know what year Wilhelm published the German edition, but it was the Book of Changes with the introduction by Carl Jung that often is the one that most people come across certainly the one I first came across. And in that, there's not just the hexagrams themselves with the various images and judgments and lines, there's a lot of other supplementary material. And in one of those sections, there's a discussion of these two figures called the Ho Tu and the Lo Shu. And I'm sure a lot of you here know more about them than I do in terms of the symbolic, interpretational, cultural, historical aspects. I'm only interested in these, I'm interested in everything, but my direct interest in these is in the numerical aspects of them. So this was the Ho Tu, and according to the legend, this came out of a river. Which river was it in China? The Yellow River. It's called the Yellow River diagram or the Yellow River map. And a sort of dragon horse kind of hybrid creature came out of the river with this pattern on its back. And it's got, basically what's going on here is you've got the numbers 5 and 10 in the centre, and then you've got 1 and 6, 2 and 7, 3 and 8, 4 and 9. In other words, the difference is 5 between the inner and outer number. The odd numbers have been coloured white and the even numbers black. And traditionally, this is associated with north, south. The Chinese put north downwards, you probably know that. But also the elements, this has been associated traditionally with water, metal, fire and wood. It's also been associated with the trigrams. According to the mythology, Fu Si derived the 8 trigrams from this, and the I Ching followed from that. Now, for me, it's fascinating that this is really among the very earliest bits of Chinese mythology, which, as we know, has real historical depth and a sort of there's a sort of weight and depth to it. I think that we can't really imagine in Europe. I think our mythology is a lot more sort of fragmented, and there's been a sort of continuity there, which is it impresses me. The idea that the earliest thing they've got is a diagram involving some numbers with some sort of pattern in it is fascinating, and it's fascinating to a lot of people, and it's led to a lot of speculation, a lot of people sort of playing with numbers and trigrams and trying to make sense of it. And I was just looking online, reminding myself, what have people found about this? What are the traditional associations? And there doesn't seem to be any clear consensus. I mean, maybe some of you know about this when we talk about it later, but I did find this image online. Just Google images search Ho Tu trigrams. I found this. It looks kind of old to me. You can't know how old that is. Google was not able to tell me where that came from. It was just in some strange website that didn't have anything to do with the I Ching. Somebody ended up there somehow. It's got a pair of trigrams in each of the 8 directions. So not only of these 4 elemental directions got a pair of trigrams, also the corners, which don't really have anything going on. And you've got both sequences. There are 2 traditional sequences. Again, a lot of you probably know this. The sequence of earlier heaven, the sequence of later heaven, the sequences that the trigrams have been traditionally organised in, or ordered in. We've got both represented around the outside of this. Now, like I said, I couldn't find any other verification of that. I'd be interested to know where it came from. Basically, the mathematician in me wants to know, can I link this pairing of odd and even numbers around the outside with these trigrams in any sense? And was there some way you could derive these sequences from this number pattern? And I'm not aware that there is, but it's the sort of thing that what you could call amateur mathematicians, people who haven't really studied mathematics in much depth, but who are fascinated by numbers. I get a lot of emails from people like this who think they've solved various hugely important mathematical problems, but haven't really understood them. But there's a sort of interest in these sorts of very accessible problems, and people will dedicate years of their lives trying to make sense of them. I can't find anything clear about the relationship between the trigrams and the Ho-Tu, but there is this very ancient myth that the trigrams originated from that. So I don't know what it means. But the Lo Shu, we're getting a little bit more into what we could call mathematics here. Now the legend is that sometime later, after some sort of great flood, there's a sort of great flood myth in ancient China. I didn't know about this until I recently reminded myself from reading up on this stuff. And I think as the rivers were receding and it wasn't the Yellow River this time, I think it was the River Lo, this being the Lo Shu, a turtle this time, and it had this on its back, which was a 3x3 grid of numbers, and if you count them, there we have it. It's what's called a magic square, and it's generally bracketed as recreational maths. The idea here is that if you add any three numbers, horizontally, vertically, or diagonally, you get 15, you get the same number. And it turns out you can make magic squares of you can make much bigger ones. I think you can make them of any size. They become harder and harder to find. It's like a Sudoku puzzle or something, trying to get everything to add up right. Again, they're fascinating to people who don't have who are fascinated by numbers but don't have any deeper understanding of maths, because anyone can understand the idea and anyone can try and find more of them. But in this case, we've got it linked to an ancient Chinese myth, and we've got it linked to the trigrams again. Traditionally, the Lo Shu is associated with the trigrams. Now, I've seen claims that the Ho-Tu is associated with the sequence of earlier heaven and the Lo Shu with the sequence of later heaven. I can't find any clear information on that. And I've also got this, again, Google Images, just looking for some sort of image to link the trigrams to the Lo Shu. I find a Tibetan image. It's got the numbers in Tibetan there in that grid. And it's got the trigrams around the outside, although it's somewhat ambiguous which way I'm supposed to read these two. I'm assuming the other 6 are the right way up. But again, however you interpret it, this is neither the sequence of earlier nor later heaven. It's a slight mutation. So I don't know where that came from. I don't know what the value of it is. I don't know if Tibetan culture influenced the decision to orient certain trigrams. So we've got this kind of unresolved muddle around these two simple mathematical figures and the I Ching. And I can't really say much more about it than that. Although what I would say is that this shows up the difference between ancient Chinese and modern Western approaches to number. Scott Davis, maybe some of you know of him, he was in 1998, I hope he still is, an I Ching scholar in Japan, and he contacted me because he was looking for a sympathetic mathematician to try to test some ideas out on. His own level of mathematics wasn't very sort of advanced, so we sort of tried to develop a dialogue. I'd forgotten all about this. I just recently found my notes, as I said, including some printouts of these emails. And he said of his experiences with other mathematicians, the mathematician soon tires of hearing about social or historical factors, but needs to be reminded that number science in its early culture was more akin to magic squares and numerology than anything purely mathematical. And it's true, the Chinese, despite having an incredibly efficient empire, clearly able to handle numbers in terms of adding and multiplying and keeping track of their accounts and managing militaries and economies and large-scale sort of grain storage and things like this. They knew how to handle numbers, but if you actually look through ancient Chinese mathematical texts, there's no evidence that they even noticed the existence of prime numbers, which are one of the real basis of number theory, the distribution of prime numbers. Any child can understand the idea of a prime number. It's just one you can't split into other numbers. And yet there's no evidence that the Chinese even noticed that, or that they were interested in noticing it. They were approaching number from another sort of direction. And I don't know if any of you are familiar with Ian McGilchrist's book, The Master and His Emissary, about brain-hemisphere relations, a sort of re-evaluation of the neuroscience of that, written from the point of view of a sort of literary theorist. Fascinating book. The feeling I get is it's almost that kind of hemispheric difference, that the ancient Chinese approach to number was more what I would call qualitative rather than quantitative. So in Western mathematics, numbers are seen as purely as quantities. It doesn't matter how you feel about them. Any associations you might have between a number and a colour or a direction or a part of the body or a time of day or a season of the year, you might have these associations in your mind, but any mathematician in the West would say, well, that doesn't matter, that's just not relevant, just forget that stuff, we're just dealing with the numbers purely as quantities. Now, a lot of non-mathematicians have got lucky numbers. Probably some mathematicians have lucky numbers as well, but that doesn't influence the mathematics. Whereas in all other cultures, really, numbers have, as well as the quantitative aspect, they're always being used for counting and usually at least adding things together. In other words, I've got this many, you've got that many, let's get together and we'll have this plus that. But all cultures other than ours seem to have taken at least as seriously, if not more so, this idea of the quantitative aspect of numbers. So with the Ho-2 and all these correspondences between these pairs of numbers and elements and directions and all sorts of other things, that doesn't make any sense to the Western mathematical mind, and Scott Davis's frustration of trying to have dialogues with both Western mathematicians reflects that. So the Chinese interest in number and how that relates to the I Ching, that's not really something I can say much about because I can't really get into that headspace, but I try to be more open-minded than your average mathematician in that I don't reject that it has some meaning or value. I just can't really say anything about it. So moving on from 1950, nothing happened at all until 1975 when an article was published in the Journal of Chinese Philosophy. Again, I'll link this, I've got a PDF, quite a low-res scan, but you can kind of just about read it. Daniel Goldenberg, The Algebra of the I Ching and Its Philosophical Implications. Sounded very exciting when I heard about it. Tracked down a copy of this. And it's a bit disappointing, really, because what it looks like to me, it looks like someone who's achieved a fairly advanced understanding of what you call abstract algebra. So we're not talking about the sort of school algebra, the x squared plus 2x equals whatever. That's not algebra in the sense we're talking about here. This is the kind of abstract algebra which deals with structures like what are called groups, rings, and fields. They're collections of objects. They might be numbers, they might not be. They might be other sorts of mathematical things like vectors or matrices, or they might be just completely arbitrary things that you give symbols to. But basically you have collections of objects and rules whereby you relate them. You have operators whereby you can combine two of these things to get another one. You're taking the ideas of adding and multiplying and subtracting and dividing from ordinary experience of number, and you're saying, well, let's just put that to one side. Let's build a more abstract version where we have things which might not even be numbers. They could be numbers, but they could be something else as well, and we'll combine them in a way which could be addition, but it might be something else. It could be multiplication, but it could be something else. And you can build, it's very hard to imagine this if you've never learned it, but you can build these abstract structures called groups, rings, fields, which have increasing levels of structure. And then you get these sorts of phenomena which then spin off from that, things called cosets. You have inverses, subalgebras, subgroups, subrings, subfields. And you can endlessly delve into this stuff. There are still huge numbers of people employed as group theorists and ring theorists. And it generally has no application to anything, sometimes in physics, but it's pure abstract mathematics. Anyway, that's roughly what we're talking about here. And Goldenberg seemingly had studied this to some extent and then found the I Ching and realised, this lends itself really well to an abstract algebraic kind of structuring, in that you can treat the collection of the 8 trigrams as having this group structure initially and then this ring structure. And the group of the 64 hexagrams similarly, and then certain subgroups of those, you can apply these structures to, and you can relate certain things in the I Ching to the mathematics, but it's just not in a way that leads to anything new. It's initially quite impressive if you know anything about the I Ching and algebra, but I read it and I was just left feeling like, well, you just sort of rephrased I don't know, it doesn't really add anything. It doesn't lead to any new understanding as far as I can see. And the conclusion it sort of says it all really, because he says, in conclusion, it may be argued that the epistemological relation between the traditional non-algebraic and this new algebraic philosophy of the I Ching's algebraically demonstrable aspects is similar to that between ancient Greek speculative atomism and modern scientific atomic theories. A sequel to this paper, further developing the significance of the algebraic method of analysis as applied to the I Ching and its philosophy, will appear in a forthcoming issue of this journal. Well, first of all, it didn't. He never followed it up. And I don't know why. I don't know what became of him. Well, I guess why. Because it doesn't really go anywhere. And the key is, he says, as applied to the I Ching and its philosophy. It's fine when it comes to just the simple structure of hexagrams and trigrams and yin and yang lines and building up these layers of structure. But as soon as you come to what any of it means or how you interpret it, the algebra really can't tell you anything. And his claim that that he compares the I Ching, the understanding of the I Ching prior to his paper and after, I mean, that makes it sound like he's a bit megalomaniacal. I don't really mean it like that. But he's basically saying now we have a relationship with the I Ching which is analogous to modern atomic theory compared to ancient Greek ideas of atoms. But I would dispute that, because we can now build, incredible materials and nuclear bombs and transistors and things. We can actually make things happen because of our understanding of atoms that the ancient Greeks couldn't have made happen. Whereas Goldenberg's algebraization, if that's the word, of the I Ching doesn't allow us to sort of develop new I Ching technologies and take it somewhere. It's just sort of, oh, that's interesting, sort of a bit of a dead end. That's how I feel about it. But if you want to have a look, it's online. Now, there's one thing in there that does merit reporting, I'd say. It's what he calls an enticing detail. And basically, he shows how you can add and multiply hexagrams, in a sense that I was saying. You've got this abstract notion of adding or multiplying, these group and ring operations. He basically shows how you can take two hexagrams and add them together and get another hexagram, or you can multiply them together and get another hexagram. Therefore, you can subtract them. And if you can subtract one hexagram from another, so you've got hexagram B and hexagram A, and you take hexagram B minus C to get, B minus A to get hexagram C, well then A plus C equals B. In other words, you can take hexagram A, and then you can add this other third hexagram that wasn't there in the first place, that you found by subtraction. It's basically the difference hexagram. You can add it on to the first one and get the second one. And he's basically arguing that if you do a divination where you have one hexagram leading into the other, because of the changing lines, you can represent that as a third hexagram. You can think of, so if I get hexagram 37 leading into hexagram 60, I can actually subtract one from the other using this very simple procedure involving binary arithmetic, basically, and find what he calls the median hexagram, or the difference. So that's, again, if you know anything about algebra and the I Ching, it's like, oh yeah, it's not wow, it's just it just falls out of the structure. Whether it means anything, that's the important thing, whether you can take that hexagram and say that is actually meaningful in terms of how we interpret our reading, or the way the hexagrams relate. I don't know, I can't comment on that. But anyway, he takes the idea of a difference between hexagrams, and then he talks about inversion differences. Now, his idea of inversion is turning a hexagram upside down. There's two ways you can invert a hexagram. You can change all the yins to yangs and yangs to yins, and get kind of a negative image. But if you take the difference between a hexagram and it's that inversion, you'll always just get yang, 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 yang. You'll get the creative, because you're basically subtracting, so you're adding 1 to 0 and getting ones. No, the difference would be the receptive, not the creative. You get all zeros. But anyway, you'd always get the same thing if you subtract a hexagram from its inverse. It's the yin-yang inverse. But if you flip a hexagram upside down and subtract, you get something else. You get something of interest. Now I can't actually make any sense of it. I've tried it. It doesn't seem to work, so I must be misinterpreting it. But I believe he didn't make this up. He basically said if you take the first eight hexagrams in the Fu C sequence, the top line there, and then you take their inversion differences, you get hexagrams number, he claims 60, 30, 45, 12, 51, 18, 33, and 0. So he's numbering from 0 to 63. So that would be the creative. So basically, he starts with the first 8 hexagrams, the top line of the Fu C. He takes their inversion differences to get 8 other hexagrams. Then he looks them up in the King-Wen sequence. Now, again, I'm sure this is all very common knowledge to you, but if it isn't, The King-Wen sequence is the one that's traditionally used in almost any I Ching you look at. The hexagrams are in this order. It has no, once you've actually, if you consult the oracle, it doesn't matter what order they're in. It's just a sort of an index. But what's interesting about the King-Wen sequence is it's not obvious. The Fu Si sequence follows a binary counting pattern. You can predict what the next one will be once you've seen the pattern. The King-Wen sequence doesn't have that kind of structure. They come in pairs. They're basically each pair is the even one is the odd one flipped upside down. So 4 is 3 upside down, 6 is 5 upside down, 8 is 7 upside down, and so on, except when they're symmetrical, where like 1, hexagram 1, if you flip it upside down, you end up with hexagram 1. So in that case, you take its yin-yang inversion, you change all the yang to yin and vice versa. So they come in pairs. The logic of the pairing is obvious, but not the order of the 32 pairs. And so, no doubt that interested Goldenberg, I mean. He took these 8 numbers that he got from the first line of the Fu Si, looked them up in the King-Wen. He got 2, 27, 29, 61, 62, 30, 28, and 1. And what's seemingly possibly of interest here is that these are 1 apart, these are 1 apart, these are 1 apart, and these are 1 apart. Although here this is bigger than that. The other ones are, so you've got 27, 28, 29, 30, 61, 62, and on the outside 2, 1. So if you reverse those, or you're a bit lenient in your idea of what's relevant, that sort of seems, as he calls it, it's an enticing detail. Problem is though, if you take the next 8 hexagrams in the Fu Si and you try and do that, it doesn't work. It doesn't work for any of the other. If that worked for all those lines, then he would have cracked the code of the King-Wen sequence. He would have understood why it's in that order, and we'd have all heard of him, because that would have been a real discovery. The kind of discovery that people have been trying to make since the I Ching became known in the West. I've been guilty of this as well, as you'll come to hear. So yeah, Goldenberg's work, I don't think it really led anywhere. It was updated in '98. Andreas Schurter, I don't know what became of him either, maybe some of you know. He wrote an article in the Oracle, the Journal of I Ching, or the Journal of Yi Jing Studies.